Okay, so what we have here is a Taylor series problem, and if you're to the point in calculus where you're doing Taylor series, then that means you are almost done. So congratulations on surviving all this time. You're almost there, and make sure you review for the AP exam. Okay, so part A reads, find the first four non-zero terms in the Taylor series expansion about x equals 0 for f of x equals the square root of 1 plus x. So something should go off in your head when you hear Taylor series about x equals 0, that it's actually just a Maclaurin series, which is the special type of Taylor. So we know that the general form is f of x equals the f of 0 plus f prime of 0 times x over 1 factorial, which is just 1, plus f second derivative of 0, x squared over 2 factorial, which is just 2, plus f to the third derivative of 0, x cubed over 3 factorial, and so on. So what we're going to do, in order to be able to write that, the first four terms, we need the derivatives of f of x equals the square root of 1 plus x. So we're going to rewrite f of x equals 1 plus x to the 1/2 to make it easier to take the derivative of. So the f prime of x, we're going to drop that 1/2 down, and we get 1/2 times 1 plus x to the negative 1/2. Now we would normally have to do a chain rule, but since the only thing in there with the derivative that's not 0 is x, we don't have to do anything because the derivative of x is just 1. But be cautious of that when you get a Taylor series problem, because there will often be a chain rule involved. So the second derivative of x, we're going to drop that negative 1/2 down from the f prime. So we have 1/2 times negative 1/2 times 1 plus x to the negative 3/2, because we're going to subtract the 1 off of negative 1/2. And then we need one more derivative because we're going out 4 terms, as shown in this part right here. So that's going to be 1/2 times negative 1/2 times negative 3/2 that we drop down from the second derivative times 1 plus x to the negative 5/2, because we've got to do negative 3/2 times 1, or negative 3/2 minus 1, excuse me. So now that we've got all those, we're going to plug in 0 for each x in that, which is what these values over here are. So the f of 0 is 1, f prime of 0 is 1/2, the f second prime of 0 is negative 1/4, and f third prime of 0 is 3/8. So now we're going to plug these numbers here into our general form up here. So the f of 0 is just 1, so that's all that's there. And then we have the f prime of 0, which is 1/2 times x over 1 factorial. Well, we know that 1 factorial is 1, so it's just 1/2 x. Next, we have the f second prime of 0 times x squared over 2 factorial. Well, the f second prime of 0 is negative 1/4 times x squared over 2. And we know that 2 factorial and 2 are the same thing. So 4 times 2 gives you 8, which is where the negative x squared over 8 comes from. And then our final term for part A is going to be the f triple prime of 0 times x cubed over 3 factorial. So we have 3/8 as the f triple prime of 0, and then we also have 3 factorial on the bottom, which gives us 6. So 3/8 times 6 reduces to 1/16, and then we have that x cubed on top from here. Okay, so part B of the problem reads, use the results found in part A to find the first 4 non-zero terms in the Taylor series expansion about x equals 0 for g of x equals the square root of 1 plus x cubed. So we are again doing a Maclaurin series, but now what we're doing is we're going to plug in x cubed for every x in this thing we found in part A, our series in part A, because g of x is really just going to be the f of x cubed. So that first term is still 1, and then when you plug in x cubed for x, it's just x cubed. It's 2 still on the bottom. And then when we plug in x cubed for x squared, we get x to the 6th over 8. And then when we plug in x cubed for x cubed, we get x to the 9th. And all our denominators stay the same. Okay, so part C of the problem reads, excuse me, find the first 4 non-zero terms in the Taylor series expansion about x equals 0 for the function h, such that h prime of x equals the square root of 1 plus x cubed and h of 0 equals 4. So this is again a Maclaurin because it's Taylor series around x equals 0. So we know that the h prime of x equals our g of x from b. So h prime of x equals f of x cubed, or h prime of x equals g of x, as we said here, that g of x equals f of x cubed. So in order to get to h of x, we're going to need to integrate the g of x. So we're going to plug in our series from part b, right here, into g of x here for our integral. So we're going to integrate each of those terms, which is what you see here. And then we also have to add a c on at the beginning because we do not have limits of integration. Do not forget your c. So to solve for c, what we're going to do is we're going to take this h of 0 equals 4 that we were given in part c, and we're going to plug in 0 for every x from what we got as our answer for our integral. And that just gives us that c equals 4 because each term has a 0, so all of those terms go to 0. So therefore, we know that h of x is approximately 4 plus x to the 4th over 8 minus x to the 7 over 56. And we left off that last term because they just want the first 4 non-zero terms. And the reason that we added on the c at the beginning instead of at the end like you might normally do for a regular integral is because when you're going one step backwards in a series, you have to remember that the derivative of a constant is 0. So whatever your constant is, it's going to be that first term, because when you take the derivative of it and it goes to 0, it's just going to go away. And that's the term without an x is always at the beginning in a Taylor or Maclaurin series.